Hello, my name is Diana Bagnall. I'm a research soil scientist with the Soil Health Institute, and I'd like to thank you for joining this recorded talk about contextualizing soil health for cotton growers and supply chains. Today's focus is going to be on the subject of soil health targets, and this is a part of a larger effort that's part of our initiative, the U.S. Regenerative Cotton Fund. So I've left this QR code up in case you'd like to learn more about the U.S. Regenerative Cotton Fund and sign up for alerts about it. So today we're going to be talking about the rationale and approach for soil health targets, and then we'll show a little bit of data from a proof of concept that we've employed in Texas and Arkansas, as well as a little bit of how we're going to report that data. I'd like to thank the Soil Health Targets team from our interns in 2021, Brent, Quanteria, and Robert, and from SHI staff, Christine Morgan, our Chief Scientific Officer, and a special thanks to Nate Looker. Nate is a research soil scientist and has done the heavy lifting with targets and provided most of the content for today's talk. So with that, let's talk about why we're here. We want to be able to contextualize and interpret soil health at the farm level. So when we're in a field, we want to know how healthy the soil can be, how healthy it is now, and how far we have to go. And so we could take some measurements, and there are many measurements of soil health, but let's take a look at one, for example. What I'm displaying in this box plot is soil organic carbon. And the reason there's a box plot is there are multiple measurements, but all of them were in a continuous cotton that was conventionally tilled and fallow, and they're in a sandy loam or a loamy sand soil. So within this single management in the single region, which was the Texas Southern High Plains, we have some variation in carbon stock. And we might ask, well, is it good if my soil has 3.9 organic carbon? Is that useful or not? And we don't really know until we have some context. One way of getting context is, I'm kind of expanding the graph out now. We still have the same green box plot, but now we see two others. In the yellow, we have a no-till and a multi-species cover, and then in the purple, a no-till with a rye cover. And all of these treatments were at a long-term research site and have been going on for 21 years. So giving these other management practices from a long-term research site is one way of answering or trying to answer the question of how well can I do. You'll note that the yellow box plot, which is a no-till and multi-species cover, on average is higher or better than the conventional till continuous cotton, but it's not statistically significantly different because those boxes overlap. However, the no-till rye cover crop in purple was statistically significantly better and different, and it had a 0.5 metric ton of organic carbon per acre more than the conventional till system. So this is helpful, but we see that there's variation between management is probably dependent upon how long they're there. Not every place is going to have 21 years worth of data. And as well, we have to wonder if we had selected different management, would we have maybe gotten something even better? The idea that we have here is to frame up why we need soil health targets. And so I'm going to expand our graphic once again and say that what we have now is this idea of all those treatments we just looked at, but for the same region, for the same soil, we could have a soil health target, something that is under an ideal management and has been there long enough that we've thought thinking it's coming to an equilibrium, and we can use it as our kind of North Star and try and approach that value. And that's really helpful, but again, we're staying within one location. So now we're going to expand our graphic again and move to an additional location. And that is some sites that are in Florida. Again, they're in a sandy loam texture, so very similar texture. But now they are receiving about 3 times the amount of rainfall that the Texas Southern High Plains were. So we have soil organic carbon values in Florida that are much higher than those values in Texas. And the 2 different treatments in Florida are in blue, a peanut cotton rotation, and in red, a Bahia grass peanut cotton rotation. So is it the fact that the rotations are different that's why we have so much higher? Is it probably has to do with the fact that precipitation is so much higher? It could be several of those things, but what this points out is that unless we had a lot of treatments that were replicated every single place, we really can't answer how good can it get. So we need a target that represents the best we can get for the Florida scenario, as well as a target that represents the best we can get for the Texas soil health group. And both of those will probably be different. So we want to make sure we're using the right target for the right place. So this is the concept, so showing you some empirical data of why we need targets and why it would make sense to have them. And to kind of hone that or recap that, I also want to show you one other slide. I've gone forward once here, and what we see now is the same treatments at the same site. The only thing that's changed is now we have wet aggregate stability instead of soil organic carbon stock. And so what that's done is it's kind of compressed the situation where the Florida sites aren't so much better than the Texas sites. And we also see that in Florida, that peanut cotton rotation, which was, it had lower soil organic carbon, but it has higher aggregate stability. This points out that even though some of the trends are the same when we look at different indicators, we need to have enough different indicators that we capture what's going on in the system, because soil health isn't just soil organic carbon. It's not just aggregate stability. It's a holistic idea. So we need indicators that complement each other. This leads us to recap that soil health targets concept, saying we need interpretable targets. So they represent the best achievable soil health management. And we look to have that optimal management by following the NRCS soil health principles. We want to minimize disturbance, keep living roots in the soil, keep it covered, armor our soil very well. Targets also need to be scalable. They need to work for Texas, they also need to work for Florida, and they need to work all over the place. And so we need to be able to have them even in locations where we don't have 20 or 30 years worth of treatment data. And that's why our targets are so important, that we uncouple long-term research from the ability to know how good can this soil get. And then locally relevant, targets that are defined as soils that have similar capacity for soil health, similar characteristics that can support their soil health. And these could take the form of inherent properties, topography, and climate. With that, I want to talk more explicitly about the idea of soil health groups, the way that we form groups and then can pick targets for each of those groups. So soil health groups will provide a framework both for site selection, but also for reporting. So we make sure we're reporting to a farmer relative to the appropriate target. And a preliminary version of soil health groups and soil health targets has already been implemented by Nate and his team in 2021. So some examples of data that could feed the development of soil health groups are soil survey data, climate products, and topographic attributes. We'd also want to take those maps and gridded products and be thinking about what groups make sense in terms of mineralogy, texture, and drainage. So I'm going to show you an example of using soil survey data and aggregating it based on some of these inherent properties. And then later on, we're going to look at an example of how texture can be important in selecting soil health groups. So this is the example of taking soil mapping units from NRCS data, which are fantastic and really useful. But you can imagine with this picture on the left, if we had to measure targets for every single one of those colors, we would be in for a lot of work. But when we use soil health groups based on map units and other inherent property data, we're able to distill it down to only 4 soil health groups in this region. And this was an example in Kansas. And that same process was used to sample in our preliminary work in Arkansas in the Delta, in the Blackland Prairie of Texas, and also in the coastal bend of Texas. So this map is showing those 3 regions. And then we have targets that are in the each of those regions represented by the dark green dots, and the gold dots are row crops that were measured in those same regions in cotton producing soils. And so there were 39 row crop fields and 52 targets in when we look at all of those data together. We've talked a lot about targets, and so I wanted to just take a moment and show you some pictures of the targets that Nate and team sampled. So we have here examples of forests, orchards, rangelands, pastures, fence roads, hayfields, even roadsides. And these represent, for each cotton producing soil group, the best management that we could find that had been in place for a long time, that had the soil covered, not disturbed, and living roots as much as possible. As well, I want to talk a little bit about the row crop fields. So there were cotton, corn, grain sorghum, soy, wheat, and oats in the fields that were sampled. And the soil health metrics or measurements that were used were soil organic carbon stocks, wet aggregate stability, and standardized microbial respiration, which is an indicator of microbial activity. I want to go ahead and show you now an example of the data that was collected for soil organic carbon. So here we have the three regions up there at the top: Arkansas, Central Texas, and South Texas, going from left to right. On the y-axis, on the left-hand side, we have soil organic carbon stock in metric tons of organic carbon per acre, ranging from probably around 5 to about 35. Then on the x-axis at the bottom, we have the soil texture groups. So for each of the regions, we have medium and fine. And then we also have two colors of box plots representing green for the targets and for the row crops, the gold color. I'll note that in Arkansas, the fine soils had very few measurements, less than 4, and so we weren't able to compute a full box plot. We do have their median shown there in a line. Certainly, we could spend a lot of time talking about these and the other data that were collected, but I just want to use this to draw out a few trends. First, we see that picking the targets are working, that organic carbon is higher in all of the green box plots on average than in the gold box plot. So it's giving us the ability to say, for this region, for this soil texture, that soil health group concept, how good can I get? But that how good we can get isn't the same when we're looking at inherent properties like texture, or we're looking across regions. So take, for example, Central Texas, the medium soil. Those two medians are really close. There's not a lot of gap between the gold box for medium soils in Central Texas and the green one. Compare that to fine soils in South Texas, there's a huge gap. So even though these are in the same state, there's really a big need to have soil health groups that make sense and say which inherent properties are informing us of how we can separate these groups and which regional properties are as well. So with that as an example, I want to show you in the time that we have remaining how we could report this data in a way that made sense to farmers so they could compare their soils to other soils within the same soil health group, but under different management. So here we have aggregate stability, organic carbon stock, and standardized microbial respiration. Those are the three measurements that we said we were going to show to the farmer. And we're able to represent the different managements with these bars. So the green on the right-hand side of each of these is the target, the yellow is the business as usual, and the blue is a soil health management system. If we measured it in this particular case for this individual farmer and his or her soil health group, they had reduced tillage to compare to. And so we're able to see that soil health status. And then the pink dot shows us that, for example, this farmer's aggregate stability was better than the business as usual, better than reduced tillage, moving towards that target. Organic carbon stock was really towards the low end. They have room to improve even within the business as usual measured near them. Whereas standard microbial respiration, really about as bad as anybody. So they have a lot of room to improve in their soil health gap for microbial respiration. This is the way we can present data to really show and contextualize how good farmers are doing and how good they can get. To wrap up briefly, including all the indicators was important to complement each other and show us how we could improve function. Those soil health groups were allowing us to capture trends in soil health across regions and soils. And those reference sites, which are our targets, give a big full picture of how soil health potential can be evaluated even when we don't have long-term research sites. There's a lot of folks to acknowledge here. I'd like to thank our sponsors, and I'd also like to thank you for taking the time to listen to this talk.